my name is Pamela Skinner and I'm a third-year senior science teacher here at Maranatha Christian School in Williams Lake, British Columbia. Our school houses 152 students from kindergarten to grade 12, and our school was once a former elementary school. We are financially supported 50% by the government of British Columbia and 50% by tuition fees. Williams Lake is a small mining and logging community in the interior of BC. As a school, we value keeping our tuition fees at a level that parents in a small community can afford. Our goal is to help our students to excel and to achieve all that they can using the resources that we have. This is why I applied for this grant. As a teacher, I want to help my students reach their potential, and I want them to be ready to step into any science environment and be able to succeed. Seeing as our school was built for elementary students, it was never designed to house a science laboratory. Thus, we have done the best with a classroom and we have retrofitted it to form a lab. These two lab benches, or these two white tables here at the front, and this countertop act as my lab benches. Last year, we took this shelving from our library and turned it into equipment storage. And I also have two metal filing cabinets at the front of the room that act as equipment storage as well. 2 years ago as well, we spent more than half of our science budget on purchasing this flammable chemical cabinet, and we also bought this fridge off of a used website. All of our non-flammable chemicals are stored in the wooden cabinets at the front of the room, including our oxidizers, which are technically improperly stored, but one thing I will do if we win this grant is to buy an oxidizer cabinet so that those are stored correctly. This past year, our administrative team here at Maranatha has committed to bringing our science lab to fruition. One of the first things we're going to do is our parent support group has committed to replacing our carpet with tile, and our administrative team has committed to building lab benches. In order to provide our students with a real laboratory experience, we not only need to improve the classroom, we need to improve our equipment. Ideally, I would like to be able to have my students design labs where they can come up with the procedure, ask me for the equipment, and I can give them the equipment. Unfortunately, at this point, I am not at that level because we don't have a lot of the basic equipment. Currently, when it comes to laboratory activities, I struggle to find the basic equipment. Our equipment currently consists of kitchen scales. We do have one digital scale that we bought this year, but one scale is not efficient for a laboratory activity. Now I can make solutions, but if it comes to a lab where my students need to make solutions, one scale holds up the line and then things just take a while. So as I said, it's not very efficient. When we need a heat source, we use camping stoves, instead of hot plates. And as I do not have a stirrer, I have spent many hours mixing agar solution for Petri dishes because we can't actually afford to buy the dishes already with the nutrient agar in it. In my science labs, I cannot perform a hydration experiment because my lovely alcohol burners do not produce a hot enough flame to fully evaporate the water that is contained within the hydrates. Since I do not have a fume hood in my classroom, I often use this picnic table out here to perform experiments that require the fume hood. However, as you can see, in Canadian winter, this is not really a favorable situation. Another area of our science department that is lacking is in our physics department. Last week I was talking about projectile motion, and I wanted to do a projectile motion lab with my students. However, I did not have a projectile launcher or any means by demonstrating projectile motion, so we used Nerf guns. What we did is we took some basic Nerf guns, and we were basically measuring the muzzle velocity of the Nerf gun and how the angle affected how far the Nerf or the darts were projected. Thus, what we did is we took a binder, and we actually used Pythagorean theorem to measure the angle of the binder, as we only have small math protractors which are not large enough and hence accurate enough to give us the correct angle of the binder. So we used Pythagorean theorem to calculate the angle, and then we launched our Nerf guns, and using tape measures, we actually measured how far our darts went. From that, we then calculated what we were looking for. Now, when I'm trying to teach my students accuracy and precision in measurements, using protractors, Pythagorean theorem, Nerf guns is not ideal. The equipment is technically hindering my teaching methods. With your help, I want to improve both the functionality and teaching environment of my classroom. I want to improve my equipment so that my students can perform basic labs. I want my students to be able to go off to university, college, or technical school with the basic skills needed to perform basic labs and with the knowledge of why we have safety procedures. I don't want them to step into a post-secondary environment and be in a science lab for the first time. Thank you for your time and consideration. I hope to hear from you soon.